Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And I welcome Rex VK7MO into the studio. Welcome, Rex.
Thank you, Justin.
A definite regular contributor, and Rex is along tonight to show us some very interesting photos, and also as part of our review of AR magazine tonight. Rex is the lead author in the latest edition of AR magazine, so can add something to some more to his story. Can I just say, if you are watching on YouTube, then please drop your name and where you're coming in from on the chat channel. So that we know you're out there, and by all means, please, ask questions along the way. We'll try and get to them. We'll keep an eye on the chat. So, AR magazine, and we'll just go across to the latest edition of AR magazine, which has a very impressive cover on it of a Aurora over where's that, Rex? Is that
that's actually Davis, despite the fact that it's attributed to Casey in AR.
Right, okay.
It also is attributed to me in AR, but that's not the correct copyright attribution. It's actually someone named Isaacs who took that photo.
Okay. So there's a few corrections that we're going to be doing tonight
yes,
along the way.
Yes.
This is the latest version of AR magazine, which has literally just come out in digital form, and it's wending its way to everyone in paper form. The focus is Antarctic adventures. I just thought it would do a very quick quick run through, and you can see there are all sorts of pictures from the. I assume these are from the contributors, the various stories that are in.
I imagine so. Yes.
Yeah, and also a bit of reminiscing about the Aurora Australis.
Yes, which is no longer here.
Correct, and the Noyina is wending its way to us.
Yes.
I noticed on the Antarctic Division website that it said that it was October the 16th, I think, is the expected arrival date. So, and I only found out the other day that we've actually got a friend who's on the crew that's coming back on it. So,
Okay.
who is usually on the Investigator, but he's coming back on the Noyina. He was one of the crew that went across to bring it back. So, yes, it was attributed to courtesy of Rex.
Yes, all untrue.
Yeah, okay, right, okay. Roger's editorial, so that's a board comment by our... Now, this is the, I think the first board comment by Scott Williams as president, so fantastic. The Spectrum Strategy Committee, Grant put together on a few of the things that we've been up to. I'm on that committee. Some WIA news and mains power safety, one of the first articles by Julie Perrins. Zygu G90 HF portable transceiver by VK7TW. Interesting little HF SDR transceiver, quite a neat little rig, and quite popular. And his Summits on the Air kit, so you can see the dipole and the walking poles, battery pack, and the Zygu. And Antarctica draws high interest by Brian Clark, VK2 GCE. And there's Dougie. Douglas Mawson, sorry.
Yes.
When I was at University of Adelaide, doing Bachelor of Science, of course, our geology lectures were in the Mawson Lecture Theatre, and
a few years before it would have been Mawson lecturing there.
well and truly. There was a bust of Douglas Mawson on North Terrace. And every time it was Douglas Mawson's birthday, the bust was always rigged out in beanie and scarf and a few other things.
Okay.
It was always Dougie's birthday, and there was usually drinks at the geology department. Okay, now here we go. Antarctica and the Australian Antarctic Program by Rex Moncur. So. Yeah, give us a bit of a sort of a summary of the article.
Okay, Justin. First of all, I was asked to do an article on Antarctica from my time as director of the Antarctic Division from 1988 to 1998, and my initial reaction was, I really can't write about ham radio for this period because I was full-time running the Antarctic Division, and
no time for ham radio.
I didn't do any ham radio that was relevant, and so I wrote a draft basically about what I felt I could write, which is about Antarctica, and I tried to link it to ham radio. Firstly, my first inkling of what the Antarctic program was about was when my dad, who was VK3LN, worked Heard Island back in 1949.
When there was a base on Heard Island.
Yes. And he was very proud to work Heard Island, and very proud of the fact that Australians were doing these important things.
Wow.
And I can remember that vividly.
Okay.
So I introduced the article on the basis of my dad's contact. My other ham radio contacts were when I had retired, and I did work Macquarie Island EME for the first time.
Ooh, okay, didn't know that.
Yes, and in fact,
23 centimetre EME?
no, 144 megs, because
Okay.
to make it work I had to send the gear down with the technician from Macquarie Island. And 144 was as much as I was prepared to.
Yeah, so what long Yagi?
One single long Yagi.
Yeah,
So,
okay.
I mean, I did have 4 Yagis at the time.
Yep, I remember that, Rick.
Yes.
Yeah.
And I also worked them on meteor scatter.
Okay.
So if we roll that through, you'll see a QSL card for the EME contact to Macquarie Island, which is there. Okay. Actually, if you go back to the Heard Island photo, this is the equipment that was in the Heard Island radio hut, except the hut had blown away when I got there in 1987.
Yeah, okay.
So it was all corroded, but you know, you could tell.
No, it's still there. It's still
the equipment survived. In some, it was actually, you know, all the aluminium had corroded and stuff. But,
So they basically left all that down there.
Well, what they did is they took the main transmitter, high power transmitter, and receiving setup to Davis when they closed Heard Island.
Okay.
But they left this gear there for potential emergency communications should someone get stranded
on Heard Island.
Heard Island.
Okay.
I think the probability that anyone would have ever been able to get it to work who got stranded there
would be pretty low.
Would be pretty low, but they had the right thought.
now the other thing about Heard Island is Heard Island has Australia's
highest mountain.
Yes. Which is Big Ben.
Yes, that's right. So, and that is Big Ben in the background.
I love it.
Yes.
So
I've actually, and it's an active volcano, and I've actually flown over the top of it.
Okay.
When there was a big red patch.
Oh, okay. So you could see lava. You could
not only lava, red hot lava.
Right. Okay.
Yes.
Okay.
When I say flown over the top, not right over the top, but high enough so you could see
into the crater.
Yes, because
okay.
With a chopper, it would be a bit of a risk going right over the top. Turbulence from the heat. And you wouldn't really want to land in lava.
Or crash land somewhere on Heard Island, really.
Yes. So.
So this is your shot.
It's not my shot. This was a shot by someone, Rick Burberry. At least they got the attribution copyright correct for this one.
Okay.
And Warren actually remembered that it was Rick Burberry's photo.
Okay. Rick Burberry. He was in a inflatable. I think he was helping with the logistics between ship and shore or so.
That's right.
And he just took a candid shot on the spot.
What a fantastic shot!
And that went to Australia Post and was produced as a postage stamp.
Okay.
Yeah.
So, there you go.
Right.
Fantastic. That's pretty impressive, and I really I wonder if anyone will ever activate Big Ben.
Right on top.
For SOTA.
No. They might have to. How close do you have to be to the summit?
Within 25 vertical metres of it. Which means you've got to go to the top of it.
Yeah. I think that one's highly unlikely.
Yeah, I think so too. Oh well.
Amazing what hams do. Yes. So
okay.
If we just roll down, we'll see the QSL card. Now that's for the first Macquarie Island EME contact.
Woohoo. So who was the operator down on?
David Taylor, who's
okay.
a VK3, I think he's.
VK3 something and something.
Yes.
Yep.
And he was running just 100 watts with a single 10 element Yagi that he built at my place.
Okay.
I wanted to work in meteor scatter, which we did.
Yeah.
And then when the Americans found out that he was there, and this was a rare DXCC,
It would have gone off.
they all wanted to work him, and I arranged a time, and I was listening at the same time, not expecting to work him, and I was starting to decode him.
Oh, okay.
And so I called him, and it probably took about an hour before we completed the QSO.
Okay.
And there were other people who had much better stations
That didn't work him.
that didn't work him because he's stuffing around working me. But given I'd set him up, I think I was entitled to,
Well and truly.
to get the EME contact. So
Well, truly.
now we
Keep going.
keep going.
Oh,
Yes.
Now.
This is a guy named Walter Hannam,
yes.
who was, in effect, the first secretary of the organisation that turned into the WIA.
Correct.
And he was also the wireless operator, electrical mechanic, etc., for Mawson's expedition. And there is a nice article on Walter Hannam that VK2 wrote on him in AR a couple of years back.
And can I just say, the transceiver that he is using there is a replica of that, because this is in Mawson's hut.
Yes.
There's a replica of that in Mawson's Hut Museum down here.
Yeah.
So if we had gone ahead with the 2020 WIA annual conference down here,
You would have visited there.
you would have visited there and been able to see that. But it wasn't to be. There was something strange about a virus that was
All right.
pandemic that was going on.
Right. Now,
Oh, look at this.
this building happens to be our radio club here, which we are in at the moment,
Correct.
but it is also the base from which the first radio signals were sent to Mawson's expedition in Antarctica. They were relayed from Macquarie Island, so they started off here, and this building is heritage listed because of its involvement in Mawson's expedition, which is very fortunate for our radio club because being heritage listed, it needed to be used for similar purposes,
Correct.
and our radio club is able to use it for similar purposes
Here.
for relatively peppercorn rental.
Ah, correct.
Yes.
Correct.
So we'll roll down. Now, one of the things about the Antarctic Treaty is all nations who are members of the treaty can inspect the facilities of any other nation who's got facilities in Antarctica
Oh, didn't know that.
to ensure that they don't do anything contrary to the treaty. And,
Okay.
and the most important thing is not
Mine.
no military or nuclear activities in Antarctica.
Okay.
And I was able to do an inspection of the Mooney station while I was part of the Antarctic Division.
Okay.
And this photo was actually taken by a guy named Tim George, who was a Russian-speaking person who had spent time in the Russian embassy.
Oh, okay.
Foreign Affairs officer.
Yeah.
And
Okay.
so he joined us for the purposes of the inspection so he could speak to the Russians. What I thought was interesting is you sort of think this is the Cold War, you know, and well, it's almost the end of 1997, but you think, well, but the reality is the Russians down in Antarctica are really friendly.
Yeah.
And you see they put the Australian flag up on their station to welcome the inspectors.
Well, there you go.
So I thought that was useful. We helped the Chinese get going in Antarctica. I'm not sure we would be welcome doing an inspection there.
Well, the French right at the moment,
Or
actually.
the French. French territory's right in the middle of ours, by the way. Yes. Okay, we'll just roll down. That was another shot that I didn't take, but they put in there of a Davis station. No, keep going. These are buildings down in Antarctica where one of the first jobs I had was to sort out this rebuilding program, which originally had been put up to cabinet at $20 million, and it finished up at costing about $220 million.
Whoa.
And getting the Department of Finance on side to finish this thing was my task.
Right, okay, okay.
Roll it down.
$220 million, my
Yeah.
goodness.
Now this is the an example of the Great Ocean Conveyor Belt.
Okay.
And the important thing about this is it's driven by the formation of sea ice around Antarctica.
Okay.
So each winter the area of Antarctica almost doubles.
Yep. Okay.
With sea, frozen sea.
Yep.
The sea freezes almost, the ice freezes almost fresh.
Okay.
And the salt in it depletes out, making the water beneath it denser.
Really salty. Yep.
Really salty. That salty water flows down the continental shelf.
Okay.
And then because of rotation of the Earth, it goes right
Pushes.
down, circulates right up into the Pacific. A little bit from the ice forming in the
Arctic.
In the Arctic, but
Okay.
most of it is driven by what's happening in the Antarctic. And the important thing about this is, this is effectively balancing out. The cold temperature is going up right up to the equator,
Yep.
and then coming back. And if it weren't for this current, the temperatures in the tropics would be a lot warmer than they are.
Yep. Yeah, yeah.
So
it's an ameliorating sort of effect.
that's right.
Yeah, yeah, yeah.
And if perchance we get enough warming so that the sea ice doesn't form,
That conveyor belt doesn't go.
The conveyor belt doesn't go.
Okay.
Now, the interesting thing is, it's not as bad as you think, because it's effectively a feedback mechanism.
Okay.
If it starts stopping to work,
Yep.
then the temperature of the water in Antarctica gets colder and it forms again.
Yeah. Okay.
So
Self-regulating.
it's a self-regulating system.
Okay.
Just what the limits of that self-regulation are, like all feedback systems, you can run into limiting.
It's the 2050 question.
But understanding that sea ice problem is one of the most important things, because it's not only evening out the temperature, it's taking oxygenated air from the surface into the deep waters, and things that live in the deep waters and rely on getting oxygen all depend on this.
And I assume that's bringing food, like
Nutrients
up into different parts of the ocean.
That's right. So it's a really important thing, and
Okay.
we haven't really solved all the problems of the conveyor belt, but we were doing some good work on that up until the time I've left.
Yeah, okay,
And it's
okay.
probably they know a bit more about it now. But
The interesting, there's that little loop into the Indian Ocean. It goes past what's that, Madagascar?
yes,
Which feeding all sorts of evolutionary cycles in
yeah,
Madagascar. and all
I
sorts of
should
stuff.
say that a number of scientists have drawn this diagram, and depending on how much detail, there are more little loops.
Oh, okay, right, okay.
That are more or less important.
Hmm.
And so this is a fairly simplified version of it, but
Okay.
uh,
And a pretty damn important one.
yes.
And I assume there are a lot of the research programs that were going on within the division was supporting and finding out more about this.
What we did was, one of the things I did is I moved our glaciology section from Melbourne down to the Antarctic Cooperative Research Centre at the University of Tasmania.
Yep.
and the CSIRO also a division of oceanography, which is down at the wharf.
Yep. Yeah.
They also joined in,
Okay.
and they actually did most of the work on understanding this,
Okay.
the oceanographic work.
Yep.
But we provided Aurora Australis to actually
It's the platform.
platform to do all the measurements.
Yep. Yeah. Okay.
And
Fantastic.
that was an important thing that happened. Now we just roll down and roll down.
Oh, I see. 1988, Bob Hawke.
Yeah.
Oh, there you go.
Well, yeah, we've. One of the things that I was involved in was negotiating. Well, the background to this is there was a convention being negotiated to regulate Antarctic minerals exploration.
Okay.
On the assumption that minerals might ultimately be exploited.
Yep. Yeah.
And they spent a lot of time, something like 10 years, negotiating this convention on the basis that there would be very strict environmental controls.
Yep. Okay.
And Australia, well, it was actually negotiated in New Zealand, but Australia took a leading role in that. And when it came for signing it and putting it into force, Bob Hawke made the decision that Australia wouldn't sign. Now, this is the first time the Antarctic Treaty system had fallen apart, in as much as normally everything has to be decided by consensus.
Yeah.
And you negotiate for years and years and you get consensus and you get agreement to what was a very good treaty. And then Australia decided, no. Well, Bob Hawke decided Australia wasn't going to sign.
Okay.
And I had to turn up to the next treaty meeting.
Persona non grata.
That's
yeah.
right. But to his credit, Bob Hawke put influence on the French, who put influence on the Belgians, and we finished up with 4 countries: Belgium, Italy, Australia and France. We were friendly with the French, really, in those days.
Back in those days, yeah.
And the other treaty nations started to recognise that this convention just couldn't go ahead because 4 nations were now not going to sign it, and everything has to be done by consensus. But we were not
the favourite kids on the block.
We were.
Yeah,
that's right. But as a result of that, we had to negotiate what ultimately became the Madrid Protocol for the protection of the Antarctic environment.
Okay.
It's called the Madrid Protocol because all the negotiations, the first one was actually done in Chile, but most of the meetings over several years were done in Madrid.
Spain, yep.
And Foreign Affairs, who leads the delegation, had responsibility. It breaks up into 2 working groups. One is sort of Foreign Affairs Political, which negotiates the head agreement,
yep.
But it then has numerous annexes, for example, on environment protection and
yep.
And so my job was to negotiate all these annexes so that it'll be practical to implement, because we had to implement it. And in fact, we the division put it into law in Australia, and our lawyers
drafted the legislation and the bills and whatever else.
That's right. And we also had to remove the dogs, which upset lots of people as part of this agreement.
Okay.
I
assume because they were not native species to the...
Well, there was... We got sort of stymied by the Brits, who came to a meeting and said they were prepared to remove their dogs because there was some argument that they introduced diseases that could get to the seals and cause problems. And there were also emotional arguments where people had found the dogs had eaten the penguins. The dogs did clever things, like they'd stand on the wire rope lines that so that the penguins thought they were at the end of their rope, and then they'd lift their leg and pitch the penguins.
Clever little dogs.
I'm not sure any of those things were that necessarily important, but the important thing for Australia was to do what the Prime Minister wanted, and we ultimately got agreement.
Okay. Cool.
So we'll keep going.
Murphy's Law.
Now, I wanted to introduce something that was similar to hams
Right.
into my article.
Okay.
And it occurred to me, most hams are familiar with Murphy's Law, and
Well, Murphy was an optimist.
yeah, and the nature of working in Antarctica is you are always up against Murphy's Law.
Yep.
And so I produced 3 examples that I had been personally involved in.
Okay.
Unfortunately, the photos that I had provided didn't fit into the article, so we will now just introduce these photos because I thought they're pretty interesting. Now, this is a gear that's...
So you're only seeing this here?
Yes. That's about 45 centimetres in diameter. It's a big gear.
Definitely.
And this gear was on the vessel called the Icebird, and I was on the vessel at the time. We were about halfway to Antarctica, and the ship had stopped, and the captain, after a while, came down to see me and said, "Rex, we've got a problem." And they had opened up the gearbox because it was overheating.
Yeah.
And
Found
they
that.
well, they didn't find it in that state.
No.
But they found a split.
Yeah. Okay.
Now, there was no ocean-going tugs anywhere. In fact, the nearest one was in South Africa. So,
You forget that.
what we had to do was at least start coming home and hope. And it turned out that the way that gear had split, as long as you went forward, it bound itself together.
Yeah.
If you went back,
Okay.
it opened itself up.
Okay.
But even going forward, it was wobbling in the bearings.
Yep.
And the temperature in the bearings showed that it was overheating if we went at more than about 2.5 knots.
Right.
And we're halfway to Antarctica, and 2.5 knots doesn't get you back very quick. And the interesting thing to me was, we worked it out, it was going to take about 3 weeks, and sure enough, at 2.5 knots, we got back to the one morning so we could see Bruny Island. And I thought, we're home. But at 2.5 knots between Bruny Island and the port of Hobart, it wasn't till about 10 o'clock at night that we got from Bruny Island back to Hobart. So that's one example of Murphy's Law.
Okay. Now, if I click this one, here we go.
The next one is also the vessel Icebird, and on this occasion, the ship had only left about 2 days before on its way to Macquarie Island, and I was at work on the weekend, and the logistics manager called me and said, "You better come down, the voyage leader wants to come back." And I said, "Why does he want to come back? He's only 2 days out." And he said, "Oh, well, there's some noises in the hold." And I said, "What sort of noises?" He said, "Oh, it's too rough. They can't inspect to see what's going on, but they want to come back." And I said, "Are they sure they've got to come back because of some noises?" And the voyage leader said, "Well, the captain believes this is a safety issue, which overrides anything that we might want to say."
Yep.
Okay. Well, when they came back, this is what it looked like in the hold. Now, there's 3 actual helicopters there. You can probably see a line across about the middle.
Oh, yeah.
That's the edge of a pontoon.
Oh, upside down. Ooh, yeah, okay.
Well, what?
So that line there.
No. Go further down. See there. See that
there.
black? No, the black line. There.
Ah, there.
Yes.
Ah.
Now, what this is a sort of a middle deck,
Okay.
And there's pontoons that fit into the deck,
Right.
which could also be used to carry cargo to shore, but
Right.
we never used it for that purpose.
Okay.
And normally we carried 2 helicopters, and there was welded onto these pontoons enough rings to tie 2 helicopters down.
Yep. Okay.
But on this occasion, we carried a 3rd, and what the chief helicopter pilot did was he just hooked the hooks over the edge of these pontoons. And once it got rough, the pontoons banged together and broke straightened the hooks, and they pulled out. And once one helicopter broke free, they all broke free.
That's pretty expensive.
Yeah. Fortunately, this was an argument between the helicopter company and their insurers,
Right. Okay.
not the Antarctic Division. But,
Cool.
and I'm not sure how that all finally, but I...
Would have been an expensive discussion.
Yes. Okay, we'll go on to the next example. This is the new ship Aurora Australis.
Woohoo!
Now, Aurora Australis had 2 engines. One was a V12 and the other was a V16.
Okay.
And the idea was, when you were working through heavy ice, you coupled both of these engines together,
Yep.
and you had a nice feedback control system which made sure that both of these engines contributed equally to the
drive shaft that I assume is with the middle of those rings.
Yes. And the problem was, whoever designed this feedback control system hadn't accounted for the fact that when you hit very heavy ice,
Yeah.
there is a step function feedback with the propeller hits the ice, and the end result was both engines drove themselves at slightly different speeds. And these massive couplings, which are about 1.20 metre 40 across.
And that's rubber in the middle, I
That's
assume.
right, that's rubber.
That's,
you can get a bit of an idea, there's a mobile phone. sitting
Oh,
here.
okay, yeah, okay.
And now, that at the time, one of the couplings wasn't so badly damaged that they were able to get back home on it.
Okay.
But by the time they got back home, both of the couplings
It was stuffed.
were stuffed.
Yeah. Okay.
So
So if both of those couplings had actually, like, literally it had broken free,
yes,
you would have had no drive to the drive shaft, I assume.
that's right.
Yeah.
Now there was a backup system, in as much as we had separate what's called axial thrusters, which can be.
This is when you come up to a wharf and you can.
Well, you can do things like that, but they were primarily for the purpose of positioning the vessel accurately while you were dropping.
Sampling rigs
and things like that.
Okay.
Now you could use those to come back at about 3 knots.
You got the same problem as your iceberg.
That's right. And that was the backup if this thing's failed.
Okay, right.
So these are, 3 examples of Murphy's Law, which the photos didn't get into the final product, but
Okay.
they're photos that I enjoy personally.
Oh no, well and truly.
Yes.
And absolutely phenomenal. Okay.
Wow.
Is this another?
Well, that was another example of Murphy's Law, which was when Nella Dan went onto the rocks. Normally, all the winds at Macquarie Island are from the west, and so they anchor the ship to the east of the island.
Yep.
But on this occasion, the winds came round from the east, and it
Drove it up onto
the anchor lost hold as well.
Yeah. Okay.
And drove it up onto the rocks. On this occasion, I was on the Icebird and had to go to Macquarie Island to sort out the mess.
So what happened to the Nella Dan? What was the outcome?
Well, when I got to Macquarie Island, the captain and his chief officers were still on the ship, convinced that it was going to be pulled off the rocks and sail away. However, the owners employed a rig tender to come and get the thing inspected and make sure that it all made sense.
Yep.
And they came to the conclusion that it was not viable, and they put it into the hands of the insurance company, who then had to sort out what to do. The insurance company decided that it should be just towed off and sunk.
Okay.
But because of the environmental risk, there's still some fuel on it.
Yep.
It had to be sunk. I think it was outside the 2,000 fathom line, which might have been about
fair way off.
Yes.
Yeah. Okay.
50 kilometres off.
Because that's a volcanic peak.
Yes.
Isn't it? Yeah.
And at the same time, the word Nella Dan actually comes from the wife of Philip Law. Her name was Nell.
Okay.
And the Danish company, trying to keep on side with Phil Law, named the new ship Nella Dan after Nell Law, his wife.
Okay.
At the time it went onto the rocks, Nell Law was essentially on her deathbed, and Phil Law wanted this ship brought back for as a museum piece.
Right. Okay.
So I was being pressured by Phil, who was pressuring ministers. You remember some of this?
Yeah, that's right. I couldn't hear it.
Yes. And at the same time, the Danes said, well, if and I did make some inquiries about whether there was anything we could do.
Yeah.
And the insurance company said, well, if you want to take responsibility for this, and
we'll wash our hands of it.
we will hand it over to you, but just bear in mind that if you tow this back to Hobart and it sinks in the Derwent, you might be up for hundreds of millions of dollars to get this ship raised and solve the problem. And so I had to tell Phil Law that his precious ship was not gonna...
probably not coming back.
So then the rig tender got down there and we had approval for it to be sunk out at the 50. And so to prepare it, they pulled it off the rocks into the harbour just to check that there were no problems. And it was still leaking, so they put a whole lot of pumps, petrol pumps onto it to keep pumping it so that it wouldn't sink before they got to the 2,000 fathom line. And when they did get to near the 2,000 fathom line, one of the pumps must have pumped dry and it caught on fire and the ship caught on fire. So their plan had been, when they got there, to remove the pumps
and let it sink.
And there's actually some special plugs on ships which you can use to make them sink.
Okay.
But because on fire, it wasn't safe to
go on the ship to get the pumps or whatever.
And so they decided that they would just let it sink. But it wouldn't sink.
Cue the circus music.
And so what happened was the only thing they could do without getting onto the ship was they had big fire hoses on this rig tender.
Oh, okay. And fill it with water.
And they were filling it with water. And it took hours to make the damn thing sink. Okay. The Danes said, oh, it went to its fiery Viking death. And I took a number of pictures
Yeah.
like this
Okay.
with the seals there at Macquarie Island while I was there.
Okay. The local residents?
Yeah. Okay, well, I think I have finished my Murphy's Law, but I can say for the 10 years I was running the Antarctic Division, just about every year Murphy's Law struck.
Okay.
In some form or another. Often we could overcome it, but
Yep.
so I've sort of wondered about this new ship
Yeah.
because as soon as you make anything new, you've got the old bathtub curve, which means all the problems start at the start and then it levels off and it works all right, and then when it gets old it fails again.
Everything fails. Starts
And
failing.
to my mind, this new ship has been designed to do anything that anyone would ever want, and it's a bit like Spectrum Lab. If you try and do everything you ever want, you can't do anything properly.
There's monolithic complexity, yes.
Yeah.
Okay.
So I think they would have been better off to have a small science ship and a cargo ship, which wouldn't have cost as much, and
Oh well.
might have given them a bit of backup, which might have been another way of doing it, but we will see.
You're allowed to say things like that these days.
Well, I think I've been away from the division long enough.
Yes, yeah,
nobody
yeah.
can criticise.
And the money's been spent and it's on its way back to us. So
Yeah.
it's somebody else's problem.
Yes, but they don't ask old directors for advice, so
No. Okay.
they're
Well,
They're
redundant.
doing politics though, don't they?
That-
Prime Minister's back to.
Well, old prime ministers don't get asked advice from the new prime minister.
They don't.
In fact, they cause problems for the new prime ministers.
Yes, right at the case in point today.
Yes.
Fantastic, thank you, Rex. That is excellent.
Okay, now we want to call Richard in. Could you tell Richard to come?
Yeah. We'll just quickly go through the rest of what's in here. There are quite a number of articles which are Antarctic based. This is one by Roger Harrison, A Confluence of Influences, Casey's 70 to 71, and an article about Casey and where it sits, an AR 77, I think, and the complementary transceiver. Now, the interesting thing here, Rex, is this is the 6 metre beacon. Come in, Richard. This is the 6 metre beacon that is actually sitting in the room next door. Which I'm not sure that Roger's aware of, but this particular beacon is actually sitting under a desk in there. So we were going to bring it out at the WIA conference as a bit of a surprise for Roger, who I assume was going to give something very similar to this talk at the conference.
Okay. Yeah.
2 stations, 3 modes and 4 hams, which is Mawson 71 and 72, and there's some great pictures in there as well.
We should have Alan in here, shouldn't we?
We should, yeah.
Make Alan come in there.
Make Alan come in here. We might as well get everybody in here. There's that article with some great pictures along the way. Off beacon and blizzards, off beams, and blizzards, beacons and bolts. KC 71, 72.
I don't know what it's about.
There you go. And
Go back to Mawson radio stuff.
We've got Warren out there as well.
yeah, we'll just get everyone in there. Yeah.
We're way back in 71 though.
Oh, it's Mawson, it's home. I've spent over 3 years there.
Right, yeah.
There you go. Now, Roger's article in here has that's the beacon that we've got next door.
I'm not sure that it is.
No?
Because I think the beacon next door's only got a single tube in the output.
Oh, okay.
Yeah, I'm not sure.
There were 6 metre beacons at other stations, weren't there?
That one was built by IPS, I think.
Oh, okay.
It's an IPS. They built 2 of them. One went to Casey, one went to Mawson, or one went to Macca and one went to Mawson.
Okay. But anyway, that jumped out at me when I thought.
Yeah, okay.
Oh, okay.
Yeah.
Mawson and teletype machine.
Yeah, Model 100.
Yeah, there you
Don't
go.
ask me how many hours I've spent on those. 3 days to do a complete rebuild.
Well,
Tear down and rebuild.
Flipping heck, that's not
Damn
bad.
close to it.
There's many hundreds of bits in those.
Springs, levers, screws, washers, gears,
Dear, oh dear.
clutches. There's
I
about
wonder-
5 different types of clutches.
What it would cost
That's
these
the
days to build
Thala
one.
Dam.
yes, that's a bit older.
That's
Yes.
the Thala
The
Dam. So that was
notice where the heli deck is on the back.
yeah, up
Yes.
here.
It's a
Not
long
where
way
those-
up. I think the story is that it used to be 1 story less high, and then they wanted a bit more cabin space, so they sliced it and added another deck, and then the heli deck went up.
Well, that's like the Everest. The MV Everest with its heli
but
deck
that
out,
was just made funny.
out the front. It was just looks bizarre.
The Thala Dan almost had as much side area as back area or anything. A side wind used to really
Push it
Pull it
over.
over,
Yeah, okay. Casey at dusk.
Yeah, that's the old tunnel, Casey
Yeah.
Tunnel.
Right. The long, thin. Line.
Well,
Well,
the thing that was,
You usually see the other side.
yeah,
With the
yeah, the theory behind Casey was that the air could flow underneath it and scour the,
which you can see that it does.
yeah.
But the tunnel up the other side wasn't sealed.
Yeah, okay.
So, but yeah, it worked.
Casey.
Casey.
There we go. The radio room at Casey.
Oh, that could be the ham shack.
Okay.
That looks like a
Possibly.
6 metre
Well,
beam,
that's
doesn't it?
correct,
Yeah.
and what 20 metre
Or-
HF or something.
Sorry, not ham shack. The emergency transmitter building.
Oh, that's it. Yes, yeah. Ooh, that doesn't look good.
No.
No, that doesn't look good. Oh, yeah. They're in the wrong place. Drilling Dipoles and DX by Keith Gooley, which is KC7475. Oh, there it is again. Slightly
Yeah,
differently
emergency
painted.
radio station.
Yes.
Or ham shack.
Um,
Usually had a Collins 30S1 linear and KWM2.
there you go.
A.
Diesel mechanic Terry Hobbs at the radio.
Oh,
And
he's in Alice Springs these days, as far as I know.
Oh, that's a bit of a difference. Antarctica to Alice Springs.
But it's amazing how many people go from remote places like Alice Springs, particularly diesel mechanics, down to Antarctica.
Remote hot to remote cold, yeah.
Yeah.
Okay. Looking down a borehole photo. Hope Still for Middle-Aged Engineers in Antarctica by Owen Holmwood.
That's almost after me.
Casey 88, 89. Oh yeah, well.
Oh, yeah.
There's that photo.
Yeah, except in his article he says there were 5 helicopters that were damaged and
No, there were only 3.
Three.
Yeah. Okay. 5 would have been all a bit scary. Taking magnetic measurements. So,
Oh, look, that's fun.
you have RF gear to look after. Yes. Reflections on the life of an Anea.
An
Edge-
Ari.
Dale Hughes.
Sorry.
Yeah.
Okay. By Dale, yes. I didn't realise Dale went down.
Neither did I.
So-
Until I just
And-
found out.
Oh, I did.
And there's a picture in here of a very young.
What year did it? Just look
hang
what
on.
year Dale went down.
Hang on.
Did he say?
93, 95 at
Well,
Davis.
he must have gone down when I was still there.
There you go. But there's a
But I
picture
wasn't
of
interested in ham radio.
there's a picture of a very young Dale here
that-
somewhere.
That's the vertical low frequency ionoson down around about 1.9 megs or thereabouts.
1.94.
Yeah. If you go back up the picture of the drawing of the antenna, is that it, or is that the normal ionoson aerial?
Yeah,
That's
yeah, I
no,
think
that's
so.
the normal ionoson aerial. Yeah,
The 4B ionoson, yeah.
yeah.
IPS. But there's a picture here somewhere. Oh, there we go. There's a very young Dale.
Very young.
So at the PDP-11.
I mean, the interesting thing, if that's a photo in Antarctica, it's not that long ago. It's only 25 years ago.
Yeah, okay.
That'll be in what got called the banana, I think.
3 PDP-11s. My goodness.
Because the building sank in
Um,
the middle.
Contacts, constraints, then AX at last. So Macquarie Island 2002-03. Peter Picorni.
Yeah.
So
After my time.
yeah.
Yeah, I know.
Well, Peter did he did the that standards talk at Gibbs. It was about coming up with a standard in from a number of world radio conferences, and we all sort of went, "Oh no, not this talk!" But it was hilarious. It was.
He used to work for OTC like I did.
Yeah. The operating position is in 0 MQI. Deep South and Deep Conversations, Casey 2021. So this is
Oh my goodness.
Getting
he's
recent.
he's currently there. So this is
Oh, yeah.
0
It is
PD
21, isn't it?
2021. Melbourne Australia.
God, what happened to 20?
And so
COVID.
now Paul's done I think some contacts with Hayden, and I think Hayden might have interviewed him. Yeah. So Richard, you worked him? Yeah. So fantastic. So this is now. He's down there, and looking very somewhat more modern. The Radio Shack in the Hobby Hut. Okay.
That's Wilkes.
Yeah. It's the old Wilkes.
The
Don't
old Wilkes.
walk on the roofs. They have a habit of
Collapsing.
letting go.
Right.
Don't ask me how I know.
And right. Okay. Now this is an ongoing article about the antenna tuning unit from Brian. And I think, the squeaky, an RF field strength indicator by Peter Parker, VK3YE, using a 555. DX Talk, so these are the standard columns. Bouvet Island update, yet again. Is it on, is it off? VHF, UHF expanding in world by VK7TW. And look at these. Recognise those? I looked at those very interestingly. They're frequency lockable frequency sources. Meteor scatter report with Kevin Johnson, which is in there, and I think Alara with Jenny, and I think that might be it actually. Yeah, and that's the advertising at the end. So really, really full of Antarctic, great Antarctic articles. So
I've got something to read then.
so definitely. So that is wending its way to people right now. So
Box tomorrow.
and you can you can download the digital version if you want to. So I thought I'd get in early and Rex said he would add some of the pictures that were missing. So
Yeah.
that's good. So anyway,
Lots of memories.
oh yes,
Yes.
yes. Thanks for the memories. Oh no, good stuff. And the Noyena's on its way to us.
Yes, apparently.
Yeah, I know it is. It is definitely. I've found out we've got friends whose husband is on it,
Oh, okay.
and is on his way back. He usually is on the Investigator, and put his name up for the crew. So anyway, I didn't even know that, but Helen went to visit her and said, "Oh, Stu's on the Nuyina on the way back," and I went, "Oh, okay."
At least you know how to pronounce it. I don't.
I only know that because I watched the video. Our video last week was the Antarctic Division version of how you pronounce it and a few other things. So
I still can't get it right, even though I've seen that.
So and tonight we've got actually for our RF viewers lots of Antarctic videos, Antarctic Division videos. They have a breaking the ice series on a whole range of different topics. So
that was found in the ceiling.
Yeah.
No, it's not mine.
So just so people know what we're talking about. And I'm not advertising.
This is 1950s, isn't it?
I'm not advertising cigarettes at all. But
we'll keep it blurred.
This was found for those people who remember Benson and Hedges' special filter. This was found in the ceiling of this building when I was putting some wiring in on the weekend. So anyway, that's anyway. So all right, we'll head into to Richard. So thank you guys.
You're welcome.
And I hope you have some great recollections. Now,
Too many.
we have Rex and Richard in the studio. Welcome, Richard.
Welcome.
And some news about your 10-metre dish and 10 gigahertz dish.
You're not from the council, are you?
I'm sure it was 10 metres.
1.8
1.8 metre 10 gig dish. So okay, over to you guys.
Yeah, well, as we reported, the first attempt at decoding the beacon, we thought it was pretty good. I was seeing some really strong signals on the waterfall, but alas and alack, there were no decodes, which was very sad because it was very cold and very dark. So,
could you actually see it? Like the
waterfall was stronger than I've ever seen. Yeah, you can see the
Oh, you can see the tones.
Yes.
You can see the whole lot. Like,
okay. And it wasn't decoding.
which was pretty good considering it was running 7 watts.
Mm-hmm.
So
now this is the beacon in Germany. So
yeah,
just
the 3 centimetre beacon that runs on 10368.024. It runs Q65E, as it turns out, on even minutes, and then CW on odd minutes.
Odd minutes, okay.
So I was looking at really nice sort of waterfalls, and it wasn't that late, so I made a phone call knowing Rex would be up. Rex, old mate, old buddy. So this is the deal. I'm seeing this, but I can't get any dig codes. So all of the responses from Rex were exactly as I'd thought. Have you checked the time? Must be on the right frequency because you can see the stuff. All the questions
I've got the
like
checklist written down.
That's right. And he's like, well, that's really strange. So I sent a couple of files, and Rex alerted me to the first couple of files I sent him. Well, he said they're too short. They're only 15-second ones. Okay. Oh, hang on. We found some others that are 60 seconds.
Okay.
And Rex said, yeah, they're very strong. Oh, they don't decode here either. So there was lots of, well, that's really strange and quite odd.
Scratching of head, yeah.
So we were planning to do some more tests in the coming weekend when the conditions are a little bit better. So Rex and I thought we'd do some tests just between us terrestrially to just make sure there was no sort of errors that sort of crept in with various versions of WSJTX and things. So the first couple of frames we sent decoded quite well, even though they were very strong. I think I was decoding Rex at like
plus 50.
plus 6 or something. So we ended up closing all the windows and turning the dishes pointing the opposite direction to each other.
Yeah. A bit like our 3.4 gig test the other night.
So then Rex was able to drop his output down to the point where I think I was decoding him at about minus 15 or 16, which we sort of thought was pretty much...
We actually got down to about minus 23.
We did, yeah.
Okay. And it was still decoding.
But we were trying to simulate all of it. And
you weren't missing a decoder.
And we wanted to test going between using a carrier of 1,000 hertz and then a carrier of 700 hertz, because the E mode is a bit wider.
Okay.
So
okay.
when in WSJTX, if you set your carrier to like 1,000 hertz,
Yep.
and you go into E mode, it goes red because it sort of goes, ooh, caution, this might be going outside of your pass band.
Right. Okay.
So one of the initial thoughts that Rex had, and as it turned out it wasn't, but we thought it might have been that with the 9700 being infinitely configurable, we might have at some point changed the pass band from going to 3 kilohertz to maybe less, or I might have had
Yep.
filter 2 enabled, which...
Yep. Okay.
So we wanted to do all the tests to make sure that we could get decodes, and sure, lo and behold, we did. And Rex is like, yeah, now he goes, I'm really perplexed, because everything sort of looks like it.
Okay.
So then there was a bit of a pause and a bit of a Rex like, he goes, just 1 second.
Just hold that thought.
There was a bit of a pause and he came back and he said, I've just decoded your files.
And how did you do that?
Wow. In WSJTX, under the general settings,
Okay.
there's a tick box that says decode after delay, after EME delay.
Up and back. Yeah. Okay.
Lo and behold, it worked.
So if you check that box, it
Yeah.
decoded.
Yep.
Yes.
So it took into account the 2.6 seconds
Yeah.
and
But if you check that box and do it terrestrially, it still decodes.
Yeah, because what it does is
how's that work?
it listens from still about when you're doing terrestrial, it listens from about -1 second to +1 second.
Right.
But when you go to tick this box for EME,
It widens the.
Well,
it
that's
goes
2.3
from
seconds.
still from -1 up to about 3.5 seconds.
Right.
Which allows for
No. Okay.
some about 1 second variation, plus
So
the
if
delay.
those, it would have then seen those signals, and been able to decode them.
Yes,
Okay.
and
That's in general settings.
yes, it's just something. See, the old JT65 used to have quite a wide tolerance, but part of getting the very best out of Q65 is just to narrow it down to exactly where the timing that you need,
Yes.
because as soon as you make the timing wider than you need,
No, it's got to do more work.
it's not only going to do more work, it's the potential of getting a false sync
Yes.
in the wider bandwidth, a wider time width.
So this is a setting that's been put in recently, I assume.
It's actually been there for a while. It was certainly there in QRA64.
Oh, okay.
And so I suspect Joe actually tightened it up for QRA64, and probably I remembered at the time, but I had forgotten.
I don't know whether
But
that was sharp.
what I thought was really interesting is once we found we could decode these files, I started doing a degradation test.
So
Now
That is the signals there.
there,
That's
that's
the
the
sync.
sync
the sync
tone,
line, so
and you
there
can
are
see
tones.
message tones. Now those message tones would actually go almost out to that white stuff.
So the band pass, the edge of the band pass.
Now, you haven't got flatten on that, have you?
No.
And so the thing sort of overreacts, and that's why you get a black part at the end.
Yeah. Okay.
And then
before
when the passband actually drops off, it overreacts to that.
and that's the line of
Yeah.
So
the
those
bright line.
bits that you can see on the odd minutes, the stream on the waterfall to the left is actually the frequency shifted for the CW. So the top one is actually a CW frame, and then the next one down is a Q65.
Oh, okay, okay.
That's how you sort of pick them apart.
And in fact, yeah, and there's your tone points there.
Yes,
Yeah.
they go
That's
much
73,
wider
there's-
than that.
Oh, yeah, no, 'cause you
in
can
the
see them out
E
here.
mode, they go much wider, and we thought they were running into that yellow.
Yep.
But
You were missing
but-
tones.
But that wasn't the reason.
No. Okay.
So that's really quite sort of easy to sort of spot.
Yeah, but once,
You go.
well, they're all the decodes that Richard was getting. So what I did is I applied degradation to these files, and I found that I could still decode this with 12 dB of degradation, and this beacon's only running 7 watts. And you take 12 dB off 7 watts, you get just under half a watt.
What for? Yeah. Okay.
And Richard, with his 1.8 metre dish, is receiving a half a watt signal on 10 gigs from Germany after it gets to the moon and bounces back.
So what's being received by the dish is sweet FA.
Yeah. So I think we can say Richard's dish is working extremely well. In fact, you're getting about 12 dB sun noise, aren't you?
About 12, yeah.
And that's exactly in line with what it should be.
With what's really
Okay.
And what did you get, 2 dB of moon noise?
about 1, but it's
okay.
because the meter that I use is one of those eBay sort of RF noise meter type things, and it's digital. It's hard to get a point. Like with 12 dB of sun noise, you can easily see it ramp up and then ramp down. You can sort of see a point, but it'd be nice to maybe have like an analog noise meter with a needle that you can sort of get a bit more feedback. But yeah, look, 1 dB was pretty nice.
So,
as it gets down close to the horizon, it's pretty hard to track on moon noise, though.
Yeah, because there's a whole lot of other
starts to get a
noise.
bit sort of washy.
but your tracking's working well too, isn't it? He's got an auto tracking system that.
So all of those were done without touching it.
Excellent.
So that went for about an hour.
Yep.
Without sort of touching it. So
Got to be happy with that.
got to be real happy with that.
Well and truly.
In fact, that's the.
So after we solved this problem, Richard went downstairs and
Decode after EME
his
delay.
wife said, "You've got a big smile on your face."
She said, "Oh, you look pretty happy." And I said, "Yeah, always." I said, "Remember the night I was out there? And it was cold and I didn't have a wind." She goes, "Yes, I remember." And I went, "Well," I said, "here's all the decodes." And she goes, "That's lovely, dear."
Okay.
So Alison pretty much appreciates the time and effort that goes in. So
Well, this is coming to the culmination of how many years of work?
1 million, it feels like.
I remember when we brought these. There is actually another one of these 1.8 dishes around somewhere.
There is.
But I remember when we brought them back, I looked at the 1.8 metre dish and I said, I'm not going to be able to use this. This is too big to manage. And Richard said, I'll have it.
Pick me.
And that sort of put him under a little obligation, which he's finally delivering on.
I'm actually really happy that it's been going on a while. And look, we're all busy. Everybody's busy doing stuff. And I know that the frame's been sort of, the tracking system's been sort of giving me a bit of grief lately, but it was only probably a month or so ago that I was pretty happy with the tracking system, and I thought, look, I really should graft the radio gear into it, you know. And I thought, I've got to put the feed in it, and I've got to drill some bolts out that are broken, you know. You know how you naturally sort of go, it's a bit hard. And then I don't know what happened. One Saturday morning I just got up and went, you know what? Today's the day. And then I think, you'd said to me something about 12 dB of sun noise. So by the end of a couple of hours I had the feed in and I'd confirmed that, and I think I rang you and said, you said about 12 dB, I'm about 12.2, and I think poor old Rex just about fell off his chair. He goes, is it working?
Oh yeah.
Yes, I didn't expect. Bear in mind, there is a bit of history to the feed. The feed getting bent at one stage.
Yes.
I thought the chances that this is going to all work perfectly.
Oh no. We had a template that we we made sure the feed was right.
And that is an article in its own right, isn't it? Really?
Well, I think once there is back on track for Gibbs Tech, I think there is a definite talk or three in this. So yes. Well, that is fantastic. Richard.
So thanks to Rex and his
Here.
It's just, and again, it just goes to show there's so many moving parts That, you know,
Oh,
one
yeah.
checkbox was like...
And Per's comments?
Per was very happy. I sent him an email to say that I'd actually sent him a photo of the decodes and a photo of the dish, and he said that he was very happy that it was being used on the other side of the world.
Excellent,
So, yeah.
excellent.
Implying that he didn't think they were using it so much where he lived.
Well, look, I think, as Rex said, it takes a tremendous amount of effort to keep such a thing going,
Well,
like
true.
a 7.2 metre dish,
Well and truly.
to sort of stop it.
And track the
Mate,
moon
track
to
the
within
moon
about
every
0.2 of a
day.
degree.
But you know, it's just a thankless task, and I think when you've got such a good service that's put on by somebody like that, we're all probably a little bit guilty of, like, you know, you look through a thing and you go, oh, next Saturday night I might see if I can hear the beacon. You don't think for a second, like, gee, I wonder if I should email her and find out if, you know, the beacon's on. You just expect it to be on. So when it is,
Correct.
it's
It's a significant amount of work to keep it on.
it's you know.
To get it there in the first place
And,
and
you know,
then keep it
because
on.
we've all got spare 7.2 metre dishes.
Yeah,
that
but
we can,
we can steer on the moon
Steer on the moon.
and have power amplifiers and
well, that's the thing. I think I'm not sure what the status of it is, but it's been running 7 watts for quite a while. They did run some high power tests
Yes, you can put a TWT
a
on
few
it.
months ago. That I remember when I decoded some stuff with a 600 dish. When I actually nearly worked Charlie. Charlie actually came on. We tried to have a contact, and I was decoding him at like +5 or something.
+5.
Yeah, he was running like 700 watts or something.
Flippin' heck.
He was testing.
Oh, well, he's got a big TWT that'll run high power.
Right.
The problem is these TWTs don't last forever if you run them at high power, so you can't have a beacon running all the time on TWT.
Okay.
But as it turns out, the 7 watts is like perfect. Like, again, as I said to Rex, in
Probably
my early days,
a bit touchy on a 60 centimetre.
I was able to decode originally the 50 watts on high power with the horn with the aperture of only 4 inches by 5 inches and get minus 23 decodes, like, which was pretty damn flash. Maybe those days are gone if it's only going to run 7 watts. But
Yeah. I need to do the 1.2 metre dish, I reckon.
Or
Which is
what about
which
the
is
1.8 that's sitting in your...
well, no. There is a little bit of Richard knows about this. There is a little bit of progress made because I now have a MIG and TIG welder. So I have some new toys.
Right.
So yes, which the intention was very much the purchase of those was to go towards building the frame.
I have found that just having a MIG and TIG welder doesn't solve the problem. You
I agree.
need somebody who can use it.
Yeah.
And I found that this solves the problem.
well, I have been negotiating with this particular person to get some training in exchange for some
I don't
whiskey
think
or
the
something.
training
I believe
happens
there's some
instantaneously.
Jemison training course.
I think you have to do it for a lot of time before you get the skill.
Correct. So.
When you were the supervisor at INCAT, if a new guy walked in and never done any welding, how long before he was good enough to...
Look, it's a real hand-eye thing, and people were way different. I had one fellow that joined the crew that was a panel beater by trade, like a really, really good panel beater, and he'd never welded aluminium before in his life. And we just sort of, with all the new people, sort of set them up down the bottom with a few bits of scrap plate. And we came back to this guy and said, "Have you done this before?" "No." "Are you sure?"
You sure?
And he
was a natural.
He just had it.
Right.
He could read the heat, and he could just. So we'd get a bit of a demo, doing some vertical and some overhead, and like within a week, we had this guy showing lots of people up. He was
Right.
Okay.
really, and then some people just struggle to ever do it, and everything in between, But look, it takes a lot of the guys I had at INCAT were like steel guys that seemed to sort of go okay, but then there was some guys that just came along and went, "Oh, so what do you do with this?"
Yeah.
And but one guy there that was hired to sweep the floor, and one day he said, "Oh, we might have a bit of a go at this." "Oh, yeah, okay. Have you done this before?" Same deal, just
No, okay. Okay.
And yeah, he ended up getting a traineeship and whizzing through it, and was one of the really well-respected, top-notch guys. Yeah.
Okay.
So
well, there you go. You never ever know.
that's exactly right. Look, it's nice to be able to sort of put about big, and look, I think in our hobby of doing this stuff, sometimes it's handy to have diverse skills.
Absolutely.
Well and truly.
It makes it all work. So.
Well and truly. Okay. All right. Well, thank you guys. That has been absolutely fantastic, and we're actually at.
We've run out of time.
No. Well, I might do a bit of a wrap up. We'll leave a couple of these things till next week, but that is absolutely fantastic, and a bit of a focus on Antarctica. So I hope people got something from that. So yeah, fantastic, good stuff. All right. And please stick around. Wrong way. I always go the wrong way. What I've got to show you is we keep banging on about PTZ cameras that we seem to we have a little bit of focus on right at the moment, because we've managed to get hold of actually that's probably one piece that you don't recognise, or maybe this is something that you recognise. I showed the Arduino controller for the PTZ cameras the other night. And this is one of the PTZ cameras that we were actually given that didn't work. The control circuit of this particular camera was somewhat not working, stuffed, whatever you would like to call it. And so I actually took this PTZ camera apart because I was absolutely fascinated by the fact that PTZ cameras do 360 degrees, and they can do 360 degrees forever. And not actually wind up cables or do anything. So when I took it apart, I noticed that there's this wonderful little thing here, which, would you believe, is a 12 slip rings connections inside that little cylinder. There are 12 connections that come out this side, and on this side, on the other side, just down in there, you can see it's not that big. There are 12 cables that come out of the top of this particular cylinder, and it is 12 slip rings that are in constant contact.
They must be amazingly small.
And they must be amazingly small, because well, you can see my finger. That is probably no more than 20 mils. So just under an inch in length, and that's about half an inch in diameter. So 12 mil in diameter and about 20 mil in length, and there's 12 slip rings in there.
Pretty damn small.
Yeah.
So that solved that problem. But you'll notice around the edge here, if I get it in the right, there, you can see down here where it's white. There's a little bit of plastic moulding that gets progressively longer and longer. Gets shorter and shorter here as we go round, all the way down to some quite fine. There we go, and then it changes into the long one. There's a little where this mounts on. There's a little. There we go. You can see just here a lead photodiode interrupter that rolls in between, so it actually it knows where it is in the position of 360 degrees because of these slots.
What resolution do you think it has?
Probably something like, I actually don't know, but I think it's probably 1,000 in 360.
So 0.3 of a degree. Yeah.
Be about that, I reckon.
My memory
something
of
like
PTZ
that.
cameras is they're pretty accurate.
Yeah.
Because I'm just thinking about how you position them. You actually put in, and it's at least 1,024 to actually tell it to go to a position.
Right. Yeah.
So
I mean, you could use that for tracking antennas.
well, I was actually thinking about this little slip ring being quite handy.
Yeah, for absolute encoders and things.
to get the connections out of something that's rotating.
Yeah.
Now the actual tilt mechanism, and you can see there's the camera there. So this whole mechanism in here contains a camera. It contains a focus, an iris, and also a zoom function in here. This is slightly more conventional. There is a little bit of the flat ribbon cable that comes in here. There is a big loop of it just here that is a loose loop, so it's enough to go. It's a little bit more than 180 degrees, but you can see that loop unwinds and then winds back up again. So this is a little bit more conventional because literally you can only go from that position to that position. You can't keep going around. But also you can see there is the same sort of encoder. There's a little LED photodiode with a little slotted ring on here that gets progressively wider and wider. So it gives the position. Little fan on here that cools everything off. That's the stepper motor. There's a stepper motor on here for the tilt, and there's a stepper motor on here for the pan. So that's a little stepper motor. There's power supply unit on here, and then the mounting, and there's a whole lot of ICs and control and bits and pieces on there. But the thing, and the you can see here there's a little tooth belt that's on here. There's a little tooth arrangement. That's the motor that
azimuth drive for the stepper.
Yep, and that goes to this stepper here.
Geez, that'd nearly move a small dish, wouldn't it?
Well,
Yeah. Oh, don't think it'll move a dish.
a balanced dish.
With no wind.
Yeah, correct. Because the thing about this is there is a little bit of holding current on those stepper motors when they're operating, but there's not much. You can actually move the pan and tilt functions, and the camera gets very upset about it because it suddenly realises that it's not in where it thinks and does a recalibrate and goes straight back to where it was last. So, but anyway, that's I just thought I'd show you.
So PTZ, pan, tilt, and zoom.
Pan, tilt, and zoom. Yeah. So and the little controller it uses. There's a couple of protocols that these use. These were set up for the Pelco D. Protocol, so that's the protocol I was actually using. So there is an industry standard protocol for CCTV cameras. This is a CCTV camera. The zoom function on it is about a 32 times zoom. So so you can basically zoom in with this sitting on a street corner. You can zoom into a face that's a reasonable distance away. So yeah, but anyway, we had the opportunity, because this one was broken, had the opportunity to take this apart. So I intend to take this bit apart as well, because I'm intrigued by the size of that camera module and what you can actually do with that camera module, and the fact that it's a 32 zoom camera, it's not your usual little camera arrangement. So but anyway, I still can't get over those. That's 12 slip rings on that little cylinder. So just off the show, just absolutely off the show. So okay, we might just a quick mention of our 3.4 gig tests that we did on Sunday. So
it's very windy, wasn't it?
it was exceptionally windy.
Very windy for RF.
On 23 centimetres, I was seeing signals. Some of those signals were going from 50 to about plus 40.
Yeah.
Really quickly. Like it was just...
And on 3.4 it was...
that on steroids.
I'm sure I heard parts of call signs clear as, and then the rest was
crap. And that was what I was getting. So Alan was in Kingston. I was in South Hobart, and Richard was at Tea Tree. Yep. And we were all pointed at the mountain using our little Yagis that were supplied, little PCB Yagis?
I used the GARC panel.
Oh, okay.
The 18
Okay.
dB panel.
Yep.
I think they're 18 or 16 or 18 dB.
Yep.
Because with the Yagi I couldn't hear anything. As soon as I put the panel on, I moved it about. Every now and again I could hear
You
voices.
could hear.
Yeah.
So if I went to a panel, we'd probably do okay.
Or if I put my system on, it's got 30 watts maybe too.
Yeah.
Or,
Okay.
or put your grid pack on it.
No,
Too
grid
hard.
packs are a little bit coming. They're coming.
Yeah. Work in progress.
Yeah.
Mm.
Oh, I thought you already had a grid pack.
Have a grid pack for 2.4.
And I've got the barbecue grill, and I've ordered the 3.4 feed.
I think he's got those in stock.
Yeah,
I think
no,
it's
he
only
has.
The, yeah, it's
He
only,
has.
only the grill.
Yeah. So still wait for the grill because that's made for the 3.4.
Yeah.
But I have a ex-AAD large
Yeah, well, I've got
barbecue grill.
those ones I've got for 2.4. I have a couple of those.
Yeah. Okay. Okay.
But look, I think it'd be nice to have something with a bit of gain, perhaps, and not as much QSB.
Correct. So anyway, that's
Work in progress.
And promising, very promising was the what I took away from our
It was
test.
a bit like it won't be long before we can have 9 on 9.
9 on 9. Mm. Well, we almost had 23 on 23
We had 18.
on the weekend.
18, that's right.
So that was
We have
that was
had
pretty
3
good.
on 3, haven't we?
We have had 3 on 3.
We have.
Yes.
3 on 3.
We've
We've actually had 4. Had Murray on as well.
There you go. See, 4 on 3.
4 on 3.
No, that doesn't make
Just
sense.
kidding.
Now, the last thing I'll just sort of say is you may have noticed that I'm wearing a particular attire that is actually a hoodie, which is a bit of merch from the Radio and Electronics Association of Southern Tasmania, which arrived tonight at the clubrooms. There are t-shirts and hoodies and cups and stickers and all sorts of stuff. So if you're interested in these and would like to purchase, then contact our secretary at reast.asn.au is where you need to contact. And they're very nice and warm. In fact, it's a bit warm in here. But anyway, I suffer for a cause. So, just very quickly, October presentation is Sunday the 3rd of October, which is the first Sunday in October. It is a BYO barbecue straight after the broadcast, and then a military radios with Peter Dodd, VK7KPC, and Kim Briggs, VK7KB. And then Wednesday, November the 3rd, all about digital voice hotspots with Scott, VK7HSE. Focus on Pi-Star and OpenSpot 3s. So that's what's coming up in the way of presentation nights. And
What time is this on Sunday?
Straight after the broadcast. So BYO barbecue, so we have a barbecue first, and then we go into the presentation after the barbecue. So, and the reason it's on a Sunday and the reason we're doing this is we are actually setting up those radios with their antennas outside, so you can have a play with military radios on Glorious AM. In a couple of cases, along with the quite innovative little antennas that come with them. So you pull out the dipole and there's little marks on the dipoles, so you pull them out to where you need to be and set it up that way. Wow. So both Peter and Kim are keen collectors. So they're coming along. Now, videos for tonight for our RF viewers. Lots of Antarctic Division ones. The very first one, which is very interesting, is about the RAAF airdrop at Mawson, where they dropped a whole lot of equipment and stores and provisions out the back of it wasn't a Hercules. What's the next one up? Galaxy, the big one. So there's lots of great vision of this and all of this stuff sliding out the back of the aircraft and hitting the ice sort of 1,200 metres up or something. So and they've got these great little depending on the weight, they have these compactable cardboard segments. So there's a pallet and then there is all of these corrugated cardboard compaction zones.
Shock absorbers.
Shock absorbers,
Yeah.
well and truly. And depending on the amount of weight, is they put another one of these in and they just keep packing them up. So if it's really heavy, there'll be 5 or 6 of these.
Okay.
And so they just literally compact when they
Absorb
when
the
they
impact.
hit. And I only know that because the during the Antarctic week, Ruben and I went out to see the C-17 Starlifter that was out at the airport for one of the Antarctic weeks and got a tour through the Starlifter. Boy, they're big aircraft. Huge, absolutely huge. So anyway, that's the first one, and then there's a whole lot of breaking the ice, which is all about some of the science programs, etc., in Antarctica. So that's our program for tonight. So thank you to Rex and Richard and our studio audience. Rogers is still in the studio audience. So thank you very much, and we'll catch you next week, and we'll have a few of the things that I didn't get to tonight. So some interesting non-radio related stories, but technology related. So we'll see you there. It's the cunning plan. So thanks for listening, and we'll catch you next time. 73 from the Radio and Electronics Association Southern Tasmania and our DATV nights. Catch you next week.